Alright, tonight we're going to talk about absolute extrema on an interval. And extrema means like extreme values of the absolute maximums and minimums. So at this point we're going to talk about when can we truncate our equation or our graph, or for example a parabola might have an absolute minimum. Such as y equals x squared has an absolute minimum at 0, 0. And so that's what we're going to be talking about today. The extreme value theorem, as long as f is continuous on a closed interval, and that looks like something like this. Let's say we're going from -2 to 3. A closed interval has the brackets. Then f will have both an absolute maximum and an absolute minimum. There'll be the highest point and a lowest point. And so when you try to find extrema on a closed interval, find the critical numbers, which we've been talking about. You evaluate the function to find the y value is all the critical numbers and at each endpoint. And so the smallest y value is the absolute minimum. The largest y value is the absolute maximum. They call it, sometimes you'll see this as the candidate's test. Candidate's test. Alright, we're going to find the absolute extrema for part A. And they gave me the interval from -3 to 1.5. So I'm going to first take the derivative and find all my critical values. So f prime of x is equal to -4x to the third minus 9x squared. And I'm going to set that equal to 0. And my greatest common factor, it looks to be like a -x squared. So I'm going to factor that out, -x squared. And so that leaves me with 4x minus 9. So -x squared is going to be equal to 0, and 4x minus 9 is equal to 0. That means x squared is 0 and x is 0. You okay, buddy? Alright, so if I solve for x, I'm going to get 9/4. And so between -3 and 1.5, I have 4 different x coordinates that I need to check. I need to check when x is equal to 0. I need to check when x is equal to 9/4. And notice 9/4 is, let's see here, is 2 1/4, so 9/4 is not in my interval. So I'm going to cross that guy out. Alright, so my options are my now one critical value and my beginning point, which is -3, and my ending point, which is 1.5. And so we're going to go and find the y coordinates for each of those, and that's going to tell me what my maximum and minimums are. Again, this is a candidate test, so we just find all the candidates. I have a 0 as one of my candidates, -3 is one of my candidates, and 1.5 is one of my candidates. And I'm just going to see which one is the highest, which one is the lowest. Alright, when x is equal to 0, y is equal to 5. Alright, when I plug in -3, I'm going to get -81 plus -3 times 27 is positive 81, so this is going to give me 5 as well. Alright, when I plug in 1.5, I'm going to get 4. So when I look at these, my absolute minimum occurs here. So my absolute min is 1.5 comma 4. My absolute max occurs with these two, when x is 0 and -3. So I actually have two absolute maxes. So absolute max occurs at 0, 5, and -3, 5. Alright, part B. Again, I'm going to find the derivative. So f prime of x is equal to 2x. And I'm going to set that equal to 0. That means x has to be 0. So again, I have a candidates test. I want to check x equals 0, and then I want to check my endpoints. X equals 1 and x equals 2. and I want to find which one of these three has my highest y value. So I'm going to plug this back into the original. So when x is equal to 0, y is equal to 1. Plug it back into that guy. When x is equal to 1, y is equal to 2. When x is equal to 2, y is equal to 5. And so in terms of an absolute minimum, this is my absolute minimum. Absolute min occurs at 0, 1. Here is my absolute maximum. It occurs at 2, 5. Alright, C, again, take the derivative. So the derivative of this guy is going to be f prime of x is equal to 1 plus 2 sine of x. And I'm going to set that equal to 0. And so 1 plus 2 sine x. Negative 1 is equal to 2 sine x. Sine x is equal to negative 1/2. I know, buddy, that phone is amazing. Alright, so parts where sine x is negative 1/2, that's going to be in quadrants 3 and quadrant 4. And so when we talk about 1/2, we're talking about 45 degrees. So we're talking about x is going to be, let's see here, 7 pi over 4 and 5 pi over 4. And so I just want to check, both of these are in my interval, so we're okay. Both of these values are in my given interval. So now I'm going to set up my candidates test. And so let me line them up. So I have my two critical values. I have pi over 4, or 5 pi over 4, excuse me. I have 7 pi over 4. And then I have my two endpoints. I have 0 and 2 pi. And so I'm going to check all the y values for each of these. Alright, cosine of 5 pi over 4 is going to be negative 1/2. And so we have 5 pi over 4 times negative 2 times negative 1/2, so plus 1. 7 pi over 4, that would be, cosine would be positive 1/2, so now we have 5 pi over 4 minus 1. When x equals 0, cosine is 1, so this will be 5 pi over 4 minus 2. And the same is true for cosine of 2 pi. This will be, excuse me, I totally screwed that up. Sorry, guys. This is wrong. Kept plugging in 5 pi over 4. Sorry about that. So here, this one is going to be 7 pi over 4, so we have 7 pi over 4. And then that would be positive 1/2, so this will be minus 1. 0 would be 0 minus cosine of 0 is 1, so this will be negative 2. And this will be 2 pi minus, well, it's essentially the same thing as 0, so 1, so minus 2. My smallest value is this guy right here. My largest value is 5 pi over 4 plus 1. And so just plugging these into calculators, just find, you can find your largest and your smallest. So this one is your absolute max. This is your absolute min. Alright, last one. I'm going to go ahead and take my derivative. So f prime of x is equal to 1 plus... What's up, buddy? You're okay. You're okay. E to the 2x times 2. And I'm going to set that equal to 0. So 1 plus 2e to the 2x. So I'm going to say that negative 1 is equal to 2e to the 2x. Divide by 2. So I have negative 1 over 2 is equal to e to the 2x. And so in order to get to this, I need to do the ln, but I have a problem. I can't have a negative number for ln. It doesn't make sense. I have a domain issue. My ln of e is going to cancel, but this right here is a problem. If you try plugging that calculator, you're going to get an error. You better get down. Yeah, Dada's home. Go get him. Go get him. Alright, sorry guys, I hope you're entertained by the fact I'm talking to my son. Anyways, what it's in blue, that's a domain issue, so that can't work. So what that tells me are there's no critical values between zero and 3. So we have no critical values, meaning there's no maximum or minimum. So we're talking about maybe some sort of curvature. Even though it's curving up or curving down, I still don't have a maximum where I have like a loop or a minimum. So our best bet is just to plug in 0 and 3 and see what we get. So I'm going to plug in 0 and now I'm going to plug in 3 and see what we get. So if I plug in 0, y is going to be 0. If I plug in 3, y is going to be 2 plus e to the 6. And so this right here is my minimum. That's my absolute min. And this right here is my absolute max. Alright, we'll talk more about this tomorrow. See you guys.